we throw things away in space. Up to that point, honestly, for 50 years, it's a throwaway culture. At DARPA, sort of the realization was, hey, what if we could do it differently? What if we could reconfigure things on orbit? What if we could literally make a new space system out of things that were up there?
This is David Barnhart. Dave is a veteran of the aerospace industry with stints at the DoD, DARPA, and Vanguard Space. And as Dave rightly puts it here, most satellites and space systems are still thrown away at the end of their useful life. And it's frankly because we get no further use out of them. But what if that didn't have to be true? What if your satellite, say, lost its solar arrays because of a meteorite strike, and you could just get them repaired? That is where my conversation today comes in. Meet the company that Dave is building, Arkisys. Arkisys is one of the first business platforms in space that would allow your satellite to be serviced, refueled, repaired robotically. Oh, and this guy? Rahul Rughani. Rahul is the chief systems engineer at Arkisys, and he's in charge of architecting this whole vision and building out the engineering aspects of the platform. Dave and Rahul plan to execute on their vision at Arkisys through their first product, the port module. The port module is a servicing destination in space where you can accomplish a number of things. You could assemble your satellite in space. You could receive power to power your payload in experiments in space. And you could even refuel your satellite just like a gas station. And it was really fun to shoot this in person right in front of the port module and the robotic arm. I hope you enjoy this conversation with Dave and Rahul. Make sure you drop a like and subscribe to the channel if you want more content like this. Now, onto the episode. Oh, and make sure you stick around to the end for some fun B-roll. And I have to say that every time the background gets more and more interesting. So, Dave, I'll start with you. What are we sitting in front of?
Cool. Well, thanks very much for coming down. Really appreciate it. You are sitting in front of a full-scale prototype mock-up of what we call the port module, the hex there. And on top of it is a robotic arm developed by Motive.
So the port module is hexagonal?
Hexagonal. It's that whole white thing that you see. It's, again, it's full scale.
Mm-hmm.
And it's what we believe to be the first true modular aggregatable platform that could go up and stand alone by itself, but you could send others up. They would connect together, and now you can grow port or stations on orbit.
And what are the individual components of the port that I'm seeing that folks can interact with?
Yeah. So with any port, obviously, you have to have berths, right? That's sort of how it works. So every one of these boxes or squares or circles that you see are essentially connecting berths or connecting interfaces for customers, whether it was payload, even ourselves. We could attach extra solar arrays to those. We could attach reaction control systems to them. So the whole thing has about 60 different berths. So the whole point is we can try to be as aggregatable as possible and have as many customers up at one time.
And I have to say, I'm also sitting with Rahul Rughani, who is the chief systems engineer. So describe your role to me.
Yeah, so I mean, thanks for having me here. And really my role is overseeing the entire architecture at Arkisys. How do we get these platforms into orbit? How do we maintain power positive states? How do we actually attach other components to them? Have them transfer their thermal load, have them supply power to these payloads. And then when they're done, swap them robotically for a new payload.
Awesome. So let's peel back a couple of decades down, Dave.
Not too many decades.
Not too many,
please.
just a decade or two. I think you've been with the DoD. You've been with Millennium Space Systems, Vanguard, if I'm not mistaken, in Germany. You've seen evolution of this. You've seen an enviable evolution of the space industry, if I put it that way. What are you seeing in the new space industry that's different than what you saw before?
Yeah. So what's not different, in all honesty, is the level of ideation that people have. I mean, years and years ago, there was already thoughts about how to do spacecraft servicing. The challenge at the time, in all honesty, was the level of technology that would support that just wasn't there, wasn't quite there. And we're talking, again, a couple of decades, right? Today, that ideation has sort of exploded. There's all kinds of wonderful ideas that new companies, whether they're young folks that are coming in, older folks that want to leave a larger company that believe that they can execute, that are coming to fruition. This whole thing called new space? I'm a little queasy about using that word. It actually has existed since the days of SDIO, believe it or not. When SDIO, Strategic Defense Initiative Office, got started, that's the group that actually pushed the really first small satellites. They pushed the concept of taking advanced technology that was used for one defense application and applying it to a commercial or a civil application. Today, the activities are fairly amazing because the technology is to the point that companies now are able to move much faster than they were 10 or 20 years ago.
Yeah, I was going to save this analogy for both of you for later, but I think since you brought it up, Dave, I'm going to emphasize it now. The analogy that I see is like the development of the World Wide Web is very analogous to the development of what I see in the space industry now. You have all of these government-run services that were for primarily defense applications that became open source to consumers to be able to build products, and then consumers build products at level 1 where people were just interacting with data in a passive way. Then we started interacting data in a more active way. You've maybe this was part of what you studied at USC, Rahul. So I'll let you take the floor on this one. Is like how have you seen that evolution play out in your time, in your PhD? If I'm working with Dave, if I'm not mistaken, and then coming up to Arkisys.
So I mean, it's definitely exploded in the past decade. It's definitely exploded in the past decade. There's been a huge growth in new startups in space, really shrinking components down, getting to be faster and quicker turnaround on missions. You're starting to see that new space companies, I know Dave doesn't like to say new space, but space startups are moving a lot faster than the primes can and turning around products much quicker.
That's a good way to put it. And a good lead into my next question to Dave is like, where was the genesis for Arkisys? Where did you get that idea? Where did the ideation phase for Arkisys begin? And at the same time, answering that question of, we're in a new space economy. I put it in air quotes, that everybody's trying different new ideas.
Yeah.
But figuring out what's going to stick and what's going to be a good contrarian bet. Where did that thinking come from?
Let's break those two up, because those are, the second one is a big one. The Genesis, in all honesty, I was lucky enough at USC to be called by DARPA. So, it's a rather unique opportunity to go to an agency whose sole goal is to think out of the box. And it's run by the program managers there. So when you get selected to be your program manager, it's really interesting because it's like Logan's Run. If anybody's seen that movie, maybe I've dated myself a little bit too much, right? Where you're given your life clock as soon as you walk in the door. Same thing at DARPA. The genesis really came there, and I failed twice. The whole deal with a program manager at the time was you want to pitch a new start. So it's very similar to the VC process, where you have a pitch deck and you go in and you talk to the directors, the director herself, and you try to convince them, hey, this is going to be the next greatest thing. Give me $500 million, right? I got thrown out twice. The third time was finally the charm, which was useful because the thing that sort of, I don't know if it was an epiphany or it was just stubbornness, is that we throw things away in space. Up to that point, honestly, for 50 years, it's a throwaway culture. You build them once. There was no way to do anything after they got to orbit, so you had to make sure they would survive on orbit. Thus, all kinds of shake and bake and quality assurance that went into spacecraft that drove the price up. You had launch vehicles that were limited. So that was the thing that sort of said, hey, they got to last when they get up there. So drive the price on the ground to optimize. Mm-hmm. at DARPA, sort of the realization was, hey, what if we could do it differently? What if we could reconfigure things on orbit? What if we could literally make a new space system out of things that were up there? So that was the genesis of the Phoenix project. And it was pretty funny because the name was much different. I came up with Phoenix when I was going up the elevator, down the elevator after I got thrown out the first time. Said, yeah, it's going to be a miracle. I'm going to have to come up with a new name. Yeah, the name's going to be Phoenix because we're going to rise from the dead, right? So,
what has been the current market demand for a service like this?
Yeah.
Like,
so this gets to this interesting approach. So let's take the concept of throwaway culture or culture of any kind. It is ingrained in the industry. It is ingrained in people's thoughts and how they do things. Changing culture is never easy, right? There has to be a really, really big push or a really, really big pull. To date, neither one of them existed. DARPA, we were sort of right there at the middle and said, hey, what could happen? So we were sort of pushing the cusp, right? Today, now there is such a flowering and growth, as Rahul said, of all these new space startups for servicing. So if you take a step back and look at it, it's transitioning optimization on the ground to now optimizing things in orbit. It's beautiful, right? And it's also sustainable, and it allows for longevity in life, changing missions. These are the key things that eventually will convince consumers, customers, sponsors to say, okay, there's something there, right?
I think I can think of like so many examples just on Transporter 10 that say were proving their technology out for the first time and say had a SATA failure.
Yes.
Just go in, SATA's always failed, right? It's those contacts.
Yes.
Transfer contacts are always so difficult to do. But if you have an easy solution or an easy strategy to go replace it on orbit, I think that's a great way to do it. So coming to you as a chief systems engineer, Rahul, how are you thinking success in the near term and the long term for a solution like this? Like, how do you architect the system in an uncharted territory in a way that it scales? Because ideally, you'd have thousands of spacecraft launching and thousands of transporters or starships coming in and being serviced as needed at the port.
So I'm interested. How are you going to do it? You're the chief engineer.
That's a great question. So one of the things we do is the port is, like Dave said, has 60 different interfaces on board. Each port module has 60 interfaces that you can attach payloads to. Those interfaces are not interfaces we make ourselves, but actually existing flight-qualified TRL-9 removable interfaces. So these can transfer power and data, and they have a mechanical lock. So any payload that attaches to our platform will incorporate one of those interfaces, and we can just attach them, give them power, collect their data, they run their mission, and then we swap them for a new one later. We also design all of our architecture to be modular, so we can add on new components after the fact in orbit. So each of these port modules, they can attach multiple together. We can attach some of our Cutter OTV vehicles to them. We can refuel other spacecraft in orbit. So everything is designed not just to be used once, but to reuse and recycle. And then we don't plan to just offer services to upgrade other spacecraft in orbit, but really to host other spacecraft. So for all of those missions on T10 that had failures, what if instead they did their demo attached to the Arkisys port? Why do they need to be all flying on their own? Why not just attach to a central station that we provide power and data, and we steadily keep our platform stable?
So if you provide power and data, what does the customer build? Like, do they just build a structure with a camera on it if they want to take pictures of the Earth?
Yes.
And that's it? They don't have to worry about, well, they might have to figure out how to get there. To the
Correct.
port.
And we get them there too.
Yeah, we get them there.
With the transfer vehicle.
With the transfer vehicle, the tender, if you will. Yes,
Yeah.
That's the point. Plus, we're also working with OTV providers, right? So really, what we've attempted to think about and reach out to the industry is it's a holistic architecture, right? That you can't just say one company is going to solve all the problems. No. Space is big, and there's a huge amount of market push that's finally coming. So that means what we've tried to focus on is, in essence, an infrastructure, if you will. It's a platform. Now, you asked the interesting question about scalability, right? How do we get scale? And Rahul hit upon it. Scale means, by definition, you have to add things together. That comes down to, as sort of esoteric and simple as it might be, is the connector. That's what it comes down to, right? So Rahul indicated we're actually working with 2 different companies. Mm-hmm. Can we shout out the companies? Can we give them positive?
More than welcome.
So 2 different companies that have actually flown their interfaces. One is NovaWorks. The other one is iBoss. One from the US, one from Germany. Why 2? Somebody might ask, Dave, just pick one, right? Mm-hmm. Because honestly, not one interface serves all, right? Mm-hmm. It's not one ring that serves all. Each one does a little bit different. And to be a commercial platform, we have to be agnostic. We have to be as open and flexible as possible. So we chose 2 because it made the most sense to us, and they've flown.
Right? Are the ring adapters fundamentally different on both on both those missions? Were they different because you picked 2 providers?
Two providers of the connectors.
Okay.
Of just the connector interfaces, right? Okay. And they have a male and they have a female side.
Yeah. So, but is that a standard spec that somebody can go look up? No.
Okay. Well, they're available.
Yeah, anyone can go buy them.
Yes.
But it's not a standard. Each company has developed their own interface based on their own vision of the market.
Yeah, I guess I'm thinking like the international docking adapter on the space station is a standard.
Right.
No, these aren't a standard, and there's as of yet no standard for these small payload attachment interfaces.
So that brings up a very good point for what I'm about to ask you next, which is how do you navigate what's the right bet to place in a system architecture perspective for a part of the industry that has no playbook? And I say playbook very intentionally because I heard it recently on a podcast with Payload and Stoke Space. Stoke Space is building a second stage reusable vehicle.
Yep.
And Andy Lapsa, the CEO of Stoke Space, used an interesting analogy that for some sections of the new space economy, like launch, there is now an emerging playbook. There's how to land might not necessarily have the details, but you know how to land the first stage of a rocket. You know what needs to be done to refurbish it. SpaceX does this. New Shepard does this. And many more rocket providers will do that. And the end state is full and rapid reusability, in my opinion, along with others. How does that industry playbook come to the world of ports in space and eventually servicing hundreds, if not thousands, of spacecraft every year in space? Either one of you can take that.
Sure. I mean, so it doesn't translate directly. There is no playbook for ISAM yet, but what we're working towards is making things as open as possible. That's one of the reasons we use 2 different interfaces. We don't want to be locked into one ecosystem, and we don't want our customers to be locked into options that we decide on, because really the customers will tell us that they want certain things, and we go back to the interface providers and say, we need something that can do this that it doesn't do yet. And so that's how we're kind of facilitating the growth of the market. But then we're also working on making things with RPO more transparent. How can we, for any space that wants to come dock with us or
define RPO for just...
Yeah. So rendezvous and proximity operations, anything in close proximity within 100 meters of another spacecraft. So typically that's been very closed and everyone guards that secretly, how to do that. We want to make things a bit more open so that anyone who wants to come and get services at the port is able to understand how to do that.
So it's interesting, the question you're asking, because it's really it's a stepwise process, because even in that launch vehicle analogy you used, there was an interplay between the technology, in essence, the risk takers or the financiers, the initial payloaders, and the regulators, because even the regulators didn't quite understand that, right? In this world, where Rahul and I were lucky enough to be part of the creation of something called Confers, which is now, it started with DARPA funding, and it was public-private, and then eventually DARPA got out of it, and it's now all private company funding that are memberships. Why is that important? Because it's basically the very first industry consortium that is attempting to answer the questions that you just asked, specifically are there standards? Should we make standards? How can we get everybody to sort of work together to enable the ecosystem to go forward instead of competing with each other?
Yeah.
Right. So it's a really interesting, right? So, and all the industry, honestly, we were on a call this morning, all the industry partners that are currently working, not only in the United States, but overseas, are helping to sort of foster that and sustain it.
Yeah. Okay. So you have two flown systems or?
So we're using two interfaces that have flown before.
Interfaces that
They have not flown on Arkisys before,
Not
but
yet.
they have flown and demonstrated on other systems.
Yes.
So what is the port arms first test like you fly mission? What's the test campaign for this guy that's going to go, and when is it going to fly?
Yeah.
Is there a date that's been set?
Yeah. So the arm itself is already flight-proven technology for motive space systems, but in our architecture, we are doing all this end-to-end testing in our lab where we do this connected to our digital twin and have it run through actual mission operations. When it's going to fly in orbit, our first mission will be in December of 2025 with our Cutter OTV spacecraft. That'll be our first IOD mission with payloads on board.
What's IOD?
In-orbit demonstration. Yes. So our first orbit demo with payloads on board. And then once that is successful in orbit, a year after that, we'll launch the full port module with the robotic arm, a full complement of payloads, and the two spacecraft will rendezvous together to demonstrate our rendezvous capabilities.
Yeah. So the way I see it from what you described to me, Arkisys is building the platform, the bus, the port modules, right? So what is the biggest challenge in all of this? Is it the port modules itself? Is it working with horizontal integration to get the robot arm working together with the spacecraft and the modules, or has it been overall system development that's been challenging?
I mean, I think it's more overall system development and getting the components developed that don't quite exist in the state we need them. So think about power systems, for example. We are building power systems that, while the order of power we're delivering is not anything revolutionary, it's the ability to shift this power to any of our 60 berths as needed, but also add on a new solar panel to any of these interfaces whenever we want to. If we want to add more capacity, we can plug in a new solar array.
Do you build your own solar arrays, or do you buy them? Okay.
No. Part of it, what we've decided to do, honestly, is to focus on, as Rahul said, the system architecture development, and instead go to proven companies that either build the components themselves and then we integrate them in. The unique thing, honestly, and Rahul's been very, very modest here. When you asked, what is the robotic arm and what could it have done, or what's your demonstration, is he actually ran through with NOAA. One of our first major demonstrations was to prove that if you have a long duration stable platform and you have a good autonomous system that's able to operate a robot arm, you could build a separate spacecraft out of components in 1 hour. So we did that.
Wow.
We demonstrated it. Yeah.
Like how granular up was the spacecraft built?
So it was pretty high up. This was, again, our partner NovaWorks, and they've created modular satellites, if you will. They call them HiSats. One HiSat itself can't really do much, or it can do a lot, but it can't fly by itself. So you add three together in an orthogonal configuration. You now have a 3-axis stabilized space platform, and then you put a payload on it. Bob's your uncle. You've got a spacecraft. So we demonstrated all that utilizing the robotic arm. And what's really interesting is just by doing that, we are learning both the positives and the negatives, where some of the errors associated that build up when you have a stable platform, the classic case of a robotic arm, the tail wagging the dog, right? We had to solve that problem. So all these things we've had to think about. The other thing, again, that Rahul is alluding to is that we do not think throwaway culture. We think longevity, and that means we have to, physician, heal thyself. We have to be able to add anything to our cells after it gets to launch, after it's launched, that can sustain and keep things going and or grow our services capacity.
Yeah. So the latest piece of evidence, right, that Arkisys has demonstrated with the use of the robot arm was to put the Gate Space's jetpack onto their spacecraft in a simulated environment. So we'll talk about that partnership with Gate Space. What was that like? What was new to learn in an endeavor like that?
Yeah, we're being happy with the partnership with GateSpace. They make interesting propulsion technology that you can add on to a spacecraft after the fact. They designed it to be added on to a spacecraft on the ground using the lightband connector that's on most ESPA-class spacecraft. We demonstrated by switching out the interface that we can use the iBoss interface instead and do this robotically, and you could do it in orbit. So we did this in a ground test, but just by doing this ground test, we learned a lot about how we can manipulate their system, how we can attach it, and we have future tests coming with them to demonstrate more capabilities.
Yeah, that'll be really exciting to see. And it was I was going to lead that question with how does one think of coexistence with your customers in a way that you don't accidentally compete with them? Just the context behind that is like when I've talked to folks like Umbra, for example, they are famously vocal about not building, say, analytics platforms in addition to their satellite imagery platform. They just provide the images, do what you will with these images. You can buy them or you can use the open data images, monetize them, do whatever you want. But we won't build the analytics platform. So in a new uncharted territory like this, how do you ensure a healthy ecosystem, Dave?
Yeah, so we've tried to think a lot about that. I can tell you that sort of going around in the various VC discussions or equity investor, their immediate question is, what is the one thing you're doing that's going to make trillions of dollars? And my answer is, we are open for space for all. We are agnostic to any vertical that is out there. And, they don't necessarily like to hear that, right? But from my standpoint, that's exactly where someone needs to be to enable and host all of these potential customers who, in the end, may end up being competitors to some sense of what we're doing. There's no question about it, right? We go back to this Wild West, this no playbook, right? Our view is, let's get this up. Let's get a capability like this up, and we'll test it. We'll stretch it. We'll push it. We'll try to test as many different new technologies or capabilities as possible. Obviously, there's going to be some that are better than others. There may actually be, and I think you alluded to at the very beginning, there is no market for space servicing today. You can't point to where the dollars are.
Yeah, there's a couple with MEV and
I was going to say, right? The one is there. Yeah. It's elongating the life of a vehicle. Yeah, that's great, right?
Yeah.
But what's interesting is when the MEV attaches, that's one thing that it does and has to stay with that vehicle for a long time. So it's demonstrated that's right?
Yeah.
So what else could be done if you could add things instead of yourself? You could add something else to a spacecraft and then go off and do it for others, right? So that's what we're really thinking about. That how do we enable business to be successful in a faster way? You can almost, I have to be somewhat careful of this analogy, you can almost think of us as a hardware, software, AWS play. All right, if you think about what does AWS do, Amazon Web Services, they provide the servers and the basic GUI infrastructure, and anybody can go develop some software and go play, right? In our case, we have a piece of hardware and software. You put whatever you want it, we'll support you.
Yeah, I totally understand that analogy, and I do think that future spacecraft, especially ones that want to be proven in space for, say, they're a small company and they don't have very much in the way of funding, so they want their mission to be successful. So if the ability to go dock with the spacecraft with the port if they have a problem, and then complete their mission and therefore raise more money into a successful business, I think that's a very good thing, and it's sort of rising cosmic tide lifts all space boats. I don't know.
Right. Yeah.
I don't know if that's the right analogy.
It's all orbits. Yeah. I don't know. Whatever it is. Right. Yes. Yeah. Yeah.
So I think that's very cool in how this economy will shake out. I hope for everybody's sake that's true.
Yeah. Yeah.
I do wonder if there's a limit in terms of how big this can get in terms of the number of customers that can that we'll need to visit every single year, every single month. Is there some sort of physical limiting factor, or is space so big that it doesn't matter?
Well, so I mean, it's interesting because we use the term port because it's an easy analogy for people to wrap their heads around, right? Where it breaks down is, unfortunately, the distance in orbit is so vast, and unfortunately, the energy required to go those distances is exponentially greater than sort of a ship on water, right? And that's where, in honesty, we sort of see the initial stages where you have to really have ports in different orbits because the energy differential is too great, right? Otherwise, it doesn't make any sense for a spacecraft to either come to a stable location and be upgraded. Instead, you just throw it away and put another one up, right?
Yeah.
The other thing that I truly believe is going to happen is that I agree with you that there's probably a limit on the number of times or the quantity of separable spacecraft that come back to do something for themselves, right? What I think, however, is going to happen is, if you think about it, what we're demonstrating by satisfying individual customers on individual berths on the port module, we are also getting ourselves prepared for the larger servicing architecture. Whether it's assembling larger things, we now have the capacity and the wherewithal to do that. Whether it's manufacturing, demonstrating manufacturing, no matter what you do in space, everybody's talking about building these big things. You need a stable platform. You got to maintain thermal stability. You got to keep point. It's basic stuff, right? But you got to do it. So our view is we're designing a system to hopefully by itself expand into the market.
I think one of the analogies that you brought up in one of your earlier interviews was the enabling mom and pop shops to be able to do this. And I see a version of this where, like, say, students at universities could just build part of a CubeSat, and they don't have to build the whole solar arrays and 9 yards to it. Just build part of it and still have meaningful experimental results at the end of the day. So I think that's a very cool thing. I'm going to switch gears to like a hot second and talk about I talk about the space accelerator you guys were part of at Seraphim. That's another new thing in our industry. There are a few companies now that are part of accelerators.
Yeah, it is.
I think Astroforge was part of YC.
Y Combinator,
That's another one that. So, what was your experience like working with Seraphim, and then just accelerators overall? Like, what was that from your perspective, Dave, as a CEO, and also from your perspective, Rahul? I was like interested to hear both.
So I had actually shied away from accelerators. Talking to various folks, it's a lot of effort to put into. Question how much effort comes out of it, or product comes out of it. But the Seraphim one, there's no question that they have focused solely on space, and they're very, very discerning as to the companies that they pick. So from that standpoint, it truly was an honor to be picked, and it made sense for us. Wow, okay, the first one we get into was that one. Had a few trips back to London. Seraphim is located there. Gate Space, not Gate. Generation Space. Their U.S. arm is here in the U.S. We had some meetings here in L.A. The coolest thing, honestly, was they took me from 0 to as many percentages that I could take in terms of understanding this brand new environment of the VC financing world, right? And as an engineer, that's just not something that we're taught, in all honesty. So from that standpoint, it was actually invaluable. The other thing that's really interesting is that the cohort, the way that they do it is they only bring a certain amount of companies, and you become part of a cohort, as they call it, right? A number of other companies the same. So we've actually made connections with several of the other company cohorts, both here in the U.S., in England, and in India, whereas we would have never been able to do that. So that to me is the most fascinating, and probably one of the best things that we've got out of it is that we now have connections internationally, which is what we want to be Arkisys.
Yeah, I'm just curious about the company in India, just because I'm from India.
Yes.
So are you able to share what company that is?
It's I always get the name wrong. Athia. Is sure? Athia. Yeah. Okay.
What do they do?
They do mission development and consulting for space industries.
Okay, so sort of like running mission optimization scenarios and
Yes.
sort of telling you
and
their best.
spacecraft development, they're trying to sort of speed things up for that, right? So they're trying to take, they're not building anything yet, but they're helping everybody else to sort of build it and build that ecosystem. So
sort of a custom solution. You come to them with a problem, and they will find you a
Mhm.
custom solution and
Yeah, very
execute
cool.
it.
The whole space economy in India is its own episode. There's a
cool.
whole launch vehicle movement going on there, similar to what's happening in the U.S. and Europe.
Okay.
As well as I'm going to be talking to the founder of Pixel soon. Pixel makes hyperspectral imagery.
Okay.
And they're doing some really cool things. But you hit on a very interesting topic, Dave, which is how is Arkisys looking at global partnerships? You clearly had very meaningful global partnerships with Gate Space.
Yeah.
How do you see the global economy evolving, especially when it comes to using ports?
Yeah. I mean, just in general, it makes it, space is global. So we started out that way. We're continuing to push that. We have letters of intent and interested parties. I would say half and half in the United States and half from overseas. One of our very first demonstrations that we ever did for our first contract activity was a real-time operation where we were operating hardware in New Zealand and Germany and the United States in multiple places at the same time, all at once. So from the very beginning, we have essentially reached out to try to make connections globally. Because honestly, from a business standpoint, a commercial standpoint, the US is amazing and wonderful, and that's great. But the rest of the world is moving really quickly in space, right?
Mhm.
So my view is I really want to, bring them together and help foster them before they go somewhere else.
I think to your point, it will be less waste if there's already a port or a hub of ports providing solar arrays for you, providing power and propulsion, guidance, navigation, and control.
Yeah.
So Rahul, I noticed that there is a visiting vessel handbook. So do you have a role in putting that together?
Yeah. So I helped write that, and that is a handbook that anyone who wants to come and rendezvous with the port can request.
So this is a payload user guide, but
for the port,
for ports,
for the port, for rendezvous.
Exactly. And I mean, the visiting vessel handbook is not so much a payload user guide. There is also a payload user guide that it's separate, but this is more of a user guide for anyone who wants to physically dock with the port. If a payload is coming up and we are handling their transport, they don't need to see this guide. But anyone who is doing their own rendezvous with our port, this specifies approach vectors. What are some waypoints that you need to stop at? What are velocities you need to maintain? Anything you need to know to physically rendezvous with our station in orbit.
What gas stations stop at to get good beef jerky? I don't know.
Exactly.
Yes.
Sounds great.
Yes. That's awesome.
I did request one, just so you know.
Yeah.
And I'm still waiting
see
for mine.
I did see it this morning.
We'll get it. Yeah, we'll get it.
This is cool. This was exciting to see. So
this really came out of the work that when we started Confers, and I mean Confers in general is pushing to attempt to work on. It was started to support rendezvous and proximity operations, either standards or guidelines, right? Why? Why does that matter? It matters because we don't want to make any more debris, right? We do not want to do that. Talk about rising tide floats all. Well, the same thing might happen, right? The very first time there might be an interaction between two vehicles that is
which
not
there already
positive.
has been.
There already has been. Then the possibility exists that hard regulation will come down. Things are going to change. It's going to make it more difficult. So the idea is to get out front of that. From our standpoint, the visiting vessel handbook really is very similar to a launch vehicle handbook. Anybody that wants to go on a launch vehicle, they give you, hey, here it is. This is how you're supposed to put it together. This is how we're going to get up there. In our case, we were trying to get out front of that and address that issue specifically with how do people come to the port? Now, almost assuredly, the visiting vessel handbook, we hope, is going to get eclipsed by potentially larger standards or guidelines that are put out potentially by an organization like Confers or others, right? But until that happened, I believe we were the first ones to sort of, take the risk and sort of say, hey, this is how it is. And, simple things that are like, what is the Arkisys coordinate system that you're using when you come up to us, right?
Yeah.
Let's sort of get that straight,
Yeah.
right?
I believe there's a certain spacecraft from
There might have been in the past. I
Yeah.
heard about that.
Yeah,
Yes.
won't name any names, but
Yeah.
that was really cool to see just on the website. Do you also plan to have like I just talked to Apex Space, and those guys have an e-commerce checkout on their website.
Oh yeah.
Are you guys planning to do something similar? Because I see a login page, and I'm like,
yes,
is this where
we are absolutely planning to do something similar. Yes.
Yeah.
Yes. That's got to be. This has to be easy. We have to make it simple.
So all of our customers can log into the portal and see. They can schedule commands to go up to their payload.
Mm-hmm.
They can request services. They can see their data as it comes in, because we collect all the data. We have transceivers on board our port, get all the data down, and then we put it all into the cloud so that our customers can access that. But not only that, when their primary mission is done, they can elect to have their payload. Let's say they were demonstrating a new technology that they tested, and they did a 3-month test campaign on our platform. Their test campaign is done, but their payload still works. They can rent it out to other customers on the port. So let's say they just flight qualified their new processor. Someone else wants to use it. We can facilitate that on our platform.
Yeah, all through the few clicks of a button, I'm guessing. So yeah, that's great.
Yeah.
It goes back to your philosophy of less waste.
Yeah.
So we have about 10 minutes here. So I want to wrap up with a couple of important questions. One, I think a lot of people in the industry are bullish on Starship, and people are going to see that the launch costs are going to further drop. Whether or not it gets to $100 a kilogram, which is what SpaceX is projecting, I don't know yet, but it's going to drop. So what is, to both of you, what is the Starship era going to do for the world of ports in space? How is that going to enable a bigger hexagon, octagon, decagon?
So, do you want to answer?
Yeah. I mean, it goes back to one of your first questions, which is about scaling, right? And the question becomes, what is the appropriate scale that supports whatever mission or activity that's going to generate revenue in orbit? It's easy to say, okay, Starship is able to now bring things up that can unfold 5 times greater than the current restrictions on Falcon or anything else. The question becomes, is that size large enough for whatever the market may drive? I honestly believe that regardless of whatever size is going to happen, the functional requirements of maintainability and being able to do things to systems that have been even unfolded or created on orbit after they get up there is still fundamentally going to be there. So the question then becomes, what is the scale required for infrastructure that supports something larger? The simple analogy, honestly, that I use is if you think about when you go to a hotel and you walk in the door and the door opens and the concierge is there and, oh yeah, it's supporting all the humans. What nobody ever sees is behind that building, there is infrastructure that supports everything, and it's operating all the time. And if that didn't operate, that big, wonderful hotel would cease to exist. So from my standpoint, what we're doing is not going to fundamentally change the functional requirements. There may be differences in sizes, but I see, honestly, my hope is that with Starship, if it drives the cost down, it democratizes even further to this lower tier of folks that are able to fly things in space, right? And we're still going to be there.
Yeah, I think you're saying that no matter the size of the port, the serviceability is independent of how big this port can get.
Yeah.
Ultimately.
Yeah.
And perhaps going to a bigger port might only enable, say, like more power systems. I'm speculating, bigger power systems, and which therefore could drive a need for better attitude control. So 6 in 1.
What's really interesting is that DARPA, I used the analogy of I used from monolithic architecture to cellular morphology, and I use that because what's interesting is what's the optimum size of any cell for anything? It truly depends. It depends on what the function is. There are millions of cells inside the human body, and look how either ugly I am, and you are, and highly intelligent we all are. And it was done by just a handful of core cells. So the question becomes again, what is the function that's going to be needed on the outside? If we want to build, let's take the word Starship and translate it to the Enterprise, Star Trek. You want to build a space dock, now size matters. The functions that we're all demonstrating here must still be done. Doesn't matter what the scale or the size is, right? So
yeah. I have two closing questions. So first one's for Rahul. What is a piece of technology in the context of port that you wish you had right now at your disposal but hasn't been invented yet, that's going to drive growth, profit, a lot of visiting vehicles, whatever you pick your choice there?
That's an interesting one. Honestly, I think it's not so much hasn't been invented, but hasn't been really fully demonstrated is refueling interfaces. Once we have refueling interfaces on board our platform, we can then go and connect to other spacecraft and share fuel. One of the things that we're working on is a modular RCS system. So imagine if you had these little pods that you could refill when you needed from a central tank, and then they have little thrusters on them, and you can attach them anywhere on our platform. Because most spacecraft have these RCS control systems to control their attitude, but they're fixed in location. As our port grows, those locations need to change as our center of mass and moment of inertia changes. So we need these little modules that can be placed anywhere, and then we can robotically reconfigure them.
Yeah, I think there are a few companies working on refueling in space, but that hasn't been fully demonstrated yet, I think. So that's a great one. I'll take that. And to you, Dave, my last question, and if you want to plug anything after, please feel free. I see that people who are successful in any industry in the world of startups, they are people who take contrarian bets that are right. You have to know that you are right, but you won't know until decades down the line, years down the line. What do you feel is the contrarian bet? What is your contrarian bet beyond Arkisys in the space economy today? I won't say new space economy. In the space economy today, what is a contrarian bet you're placing that could facilitate, more success to Arkisys?
Honestly, it's the view at the moment that you have to have one function, one generation of cash, one specific thing before you can become successful. So our contrarian bet, in all honesty, is that I don't believe that. I believe the platform and the ability to be agnostic and open to as many people as possible is the right ultimate way to go.
Do you have any advice for founders in the space industry? Anyone who's founding either a hardware company or, like, say, a software company in the space industry? Do you have any advice for them?
Ask me that in a couple of years, and then I'll provide.
Well, in that case, I will be back in a couple of years. So, well, Dave, Rahul, thank you so much.
Pleasure.
Thank you.
Honestly,
It's a pleasure.
Yeah.
So,
No, thanks very much.
thank you.
Yeah.
Thanks for sticking around. And as promised, here's some B-roll.
Hey guys, I request that you put Brad Pitt's face over me if you can.
No.